Okay, it looks like we charted the median ages of first marriage for men and women in the U.S. and England over the last century, from 1900 to 2000. Okay, all right, this is going to be a command of evidence quantitative question, I believe, and sure enough, we want to use data from that graph to support the student's assertion. Okay, here's his assertion. Let's read what's going on here. A sociology student is reading an essay on the median age of first marriage in Western countries throughout the 20th century. The author of the essay cites factors common to these countries that the author believes caused an increase in the median age of first marriage. Okay, so median age has gone up for first marriage, and that's due to new technologies that shorten the time needed for domestic chores, making two-person households less necessary and living alone more viable. The student asserts that beyond these factors, there must be additional ones specific to particular Western countries that influence the increase of age at first marriage. So he's asserting that there are other factors beyond just the technology change that are influence the increased first marriage age. How would we tell that from the chart? The other factors, because the chart itself does not say anything about factors. It's just the ages over time. Well, the way we tell that is differences in aging among differences in median ages over time as the groups. So if we look at it, say the 1900 to 1950 block of time, well, they're pretty much flat, although it looks like the US men and women are going down slightly, whereas the European, the English, go up slightly. So that is a difference that would be due to other factors, right? So we're really looking for a difference. And the biggest difference I hear is, it looks like, is from 1950 to 1970. Here, the U.S. stays the same or goes up slightly, and the England men and women come down a fair bit. So we have one going down, the other going up, and obviously there are other factors at play. It's not just technology, because they're going in different directions. Now, this is curious, though, because the question prompt technically asks for other factors that influenced the increase of age at first marriage. So if it influenced the increase, technically those factors that caused a decrease, like right here, would not be applicable, right? And we don't want not a factor in the question prompt, because that is technically not an increase. So that can be a factor affecting an increase as a factor causing a decrease. I may be getting a little picky on that, but literally the definitions here can be very particular. And since this one is technically going down versus this one going up some, probably these are not going to be the right areas. The most salient difference here, which I know I'm looking for, isn't around this 50 to 70 period. That only leaves 1970 beyond. What's going on here? Well, we have the US going up, but we have, it looks like, England going up faster. So that's another difference, and those are both increases. So let's take a look at our answer options. Between 1970 and 2000, the median age of first marriage rose more sharply for men in England, than it did for men in the United States. Okay. Note, this does not say anything about the women. That was true for the women too. But this is evidence from the graph that supports the student's assertion. It might not be all the evidence to support it, but it is evidence that supports it. So this looks good. Let's check the other answer options. In England and Wales, the median age of first marriage was consistently higher for men than for women between 1900 and 2000, but this is not always the case in the United States. Okay, so this is true, probably, that first part. I believe the men were above the women. Yes, the stars are above the black triangles. Okay, but not true for the U.S. Actually, the squares are above the circles, which is the U.S. always. They say it's not the case. So this is actually not true. This is, not true, not accurate to the chart. Okay, it was always the case in the United States as well. C, the median age of first marriage for men in England and Wales was lower in 70 than in 1950 or 1990. So this could be a tricky answer because the biggest difference, if you realize that we're looking for some kind of difference between two of the things being measured here on the chart, the biggest difference you might zero on here is right on this 1950 to 70. One's going down, one's literally going up. The only place that's happening, noticeably so. So you might think, oh, that's the area where I need my answer. So that could be the answer, but that's not going to be the answer because the median age of first marriage for men in England and Wales was lower in this year than it was in the other 2 years. That is not a comparison. This is simply not a comparison. The correct answer here has to be essentially have two parts, a comparison. So we need a comparison. So that can't be right, even though it looks like a very interesting period on the graph. And a student's eye, in fact, my eye at first zeroed in on that part of the graph too. But I realized for the condition itself, it's probably not right for that. And this is definitely not right because it's not a comparison, which is what we need to show that there are other factors going on here. D, between 1900 and 2000, the median age of first marriage for women in England and Wales was consistently higher than for women in the United States, as was the case for men. So first, is it accurate? It was higher than for women. Yes, okay. Yeah, that's true. The median age first marriage for women in England and Wales consistently higher than for women in the United States. Okay, that's true. The triangles are above the circles. This is accurate to the chart. However, this is not relevant. Okay, we are having a comparison here, but it's not a relevant comparison. We need to figure out what other factors other than technologies, which should cause that median age of marriage to go up over time, what other factors would apply. In other words, we want to see a change in increase of one versus the other, which was answer choice A, and that would show there have to be some extra factors. Otherwise, it would always be going up or down at the same pace. This just one says one's higher than the other. Was at the beginning, it was at the end. At any given point, it's kind of just like a snapshot. It's not measuring change. This cannot be right. That's not the correct answer. The correct answer is going to be A. You had one, England going up fairly quickly, and the United States only going up somewhat. So more so than in previous years. So some other factor had to be at play. We need to see some differential growth rates. They both had the technology, you can presume. So why would they grow at very different rates? That's probably the best evidence for the student's assertion. Okay, again, looks like we have a quantitative command of evidence. We have a table. We're going to have to, this case looks like complete the text. So use data from the table to complete the statement. Okay, what's the table about? We're going over a course of years. We're showing agricultural, manufacturing, and services employment. Percentage of total, and then looks like the same thing for the US. So who knows? It might be a trend over time, might be a comparison of the US to France. These are typical things we'd want to see. Might be a comparison of one sector versus another. And what's clearly happening is the story looks like agricultural employment in the US and France went down considerably over the century. Manufacturing stayed kind of the same, and services went up, almost like people went from the farm to doing services, maybe in the cities or elsewhere, who knows, but that's not in the table. Anyway, let's read it. Over the past 200 years, the percentage of the population employed in the agricultural sector has declined in both France and the US. Yes, while employment in the services sector, which includes jobs in retail, consulting, real estate, etc., has risen. Yes, substantially. However, so now we're getting our contrasting statement that's going to lead into our prompt. This transition happened at very different rates in the two countries. Well, that's kind of odd because it looks like they happened at very similar rates. We went from 64 to 3, 68 to 2, went from low double digit to 14 to 76, 13 to 80. Those are pretty similar numbers. So however this transition happened at very different rates, Okay, that's their statement, so we have to take them at their word. This can be seen most clearly by comparing the employment by sector in both countries in what? In certain periods of time, if we do a quick scan of the answer choices. Okay, so over long periods of time, yeah, the numbers look the same, but there are probably some sections of time where they're not. And let's take a look. So we are comparing specifically what, but just by sector in general, from 1900 to 1950. So we're looking for the numbers not being the same. They're moving at very different rates. That's what we're looking for. So 1900 to 1950, what do we have? 43 to 32. And in the US, 41 to 14. Yeah, that's a pretty significant difference. Here we're going down 11. Here we're going down, looks like 27. That's a pretty significant difference. And in services, we're going up 7. And services, we're going up 22. Yeah, that's a pretty significant difference too, right? And manufacturing looks, again, it's the boring one. It's about the same, 29 to 33, 20 to 33, more or less the same. So this period from 1900 to 1950 is indicating different rates. That's going to be our answer, okay? 1800, let's check this, 1800 to 2012. So the whole period, well, that's what we looked at first. We said, no, those are very similar numbers. So that's not showing any growing at different rates. 1900 to 2012, let's see, that's 43 to 3, 41. Now, even that's kind of similar. So that's not going to beat answer choice A. 1800 with the employment by sector in 1900. So that would be just the first 100. No, 64 to 43, 68 to 41. A little, not that much different in services either. No, those are pretty consistent. So 1800 and 1900 is pretty consistent. Nope, the only standout is A, and that would be our answer to the question. Okay, we've got a column chart, which usually comes with two different columns. In this case, the two columns measure managers and department leaders. We can see the numbers are going up for both over time. And we can see it's going more so for the department leaders. And the department leader is always greater than the dark bar is always greater than the light bar. So the department managers are always more. So this average number of individuals reporting the CEO. Okay, I think I understand the graph. Let's see what the story behind it all is. I'm going to need to support the conclusion of the researcher. So this is a strength and weakens type question, not going to be a complete the text. So I'll need to figure out what that conclusion is. Okay. And it's probably here in the findings, usually in the last sentence or two. Considering a large sample of companies, economics experts, blah, 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 assessed the number of managers and leaders from different departments who reported directly to a chief executive officer, the CEO. According to the researchers, the findings suggest that across the years analyzed, there was a growing interest among CEOs in connecting with more departments. So that's it. That's the conclusion we want to analyze or find evidence supporting it. There's a growing interest for the CEOs to connect with their departments, which would probably be represented by the department leaders. And is that true? What shows this? So the number for the CEOs and department leaders, the dark bars, are definitely increasing at an increasing rate. So that's kind of hockey stick up. That's good. And actually the differential versus the managers themselves is increasing too. So that might be representing the same idea as well. I think the absolute level of the numbers, 2, 7, 3, 100, I'm not sure that really makes any difference here. So let's look at the answers. The average number of managers and department leaders reporting directly to their CEO didn't fluctuate from 95 up to 2008. That's not true. Of course it fluctuated. The numbers went up. We saw it in the chart. B, the average number of managers reporting directly to their CEO was highest in the 96 and 01 period. No, in the middle, it was higher in 2001 and 2008. So again, this is not true. It's just simply not accurate to the graph. C, the average number of department leaders reporting directly to their CEO was greater than the average number of managers reporting directly to their CEO in each of the 3 periods studied. Okay, so this is focused on the differential. Does that say that there's a growing interest to connect with more departments? No, that says there are always more department leaders that CEOs connect to from the beginning to the end, so that shows no change there. There's nothing we can conclude to answer our condition. D, the average number of department leaders reporting directly to their CEO rose over the 3-period study. Yeah, the bar went up, right, for the department leaders, and that's going to be our answer. That shows a growing interest over time to connect with literally in absolute numbers more department leaders. D is the answer. Okay, so we have a column chart here with, again, as always, different columns over time, and we're measuring REM sleep as a percentage of baseline. Mean difference from baseline was not statistically significant. Okay. And fur seal REM sleep on land after an extended period in water. Okay. And what was that percentage of baseline on different days after an extended period in water coming back to land? We have 3 different seals tested. Okay. So let's see, is this going to be supporting weakening, or is this going to be a complete the text? It's going to be a complete the text, right? So we need data to complete the text. Let's read the paragraph and see what's going on here. Research suggests that REM sleep in animals is homeostatically regulated. Don't know what that means, but they're going to tell us after the colon here. Animals compensate for periods of REM sleep deprivation by increasing subsequent REM sleep. Okay, so they actually have to make up the REM sleep. If they don't get it, they have to get it somewhere later. When on land, fur seals get enough REM sleep, but during the weeks they're in the water, they get almost none. So in a study of fur seal sleep habits, researchers recorded the REM sleep as a percentage of baseline of fur seals once they'd returned to land. So they're trying to make up for all the lost REM sleep. Okay, REM sleep is where you kind of dream and your eyes twitch and your kind of brain resets. So it's very helpful. When the examples on the test are something that are easier for you to understand and relate to, it makes it much easier to solve the problem, work through it. If you have experiments and things you just don't know the names of and you don't understand the experiments or the situation, very, very difficult in many cases. Anyway, that was just a side note. Let's go on. They concluded that REM sleep may not be homeostatically regulated in fur seals. So that means the fur seals don't show a lot of REM sleep when they come back to the land, because they would need that to make it up. Citing as evidence the fact that the seals in the study, what would complete the blank? The seals in the study on day 1, their percentage is a lot higher for 2 of them, but not the other. And then on day 2, it's higher for 1 of them, but not 2 of them. Yeah, I mean, they get some extra sleep, but some of the, I guess we would say the fact that the seals in the study don't all exceed baseline. So one would think on the first 2 days back, if they're away for the water in a while, they'd be shooting over the baseline, all of them, on each of the days. And we don't know how long it really takes for them to get or make up their REM sleep if they do, so I'm not sure how significant the day 1, day 2 difference really is, except for the fact that on day 2, it just goes down in the middle gray case, that far left bar. The fact that it didn't change on the other 2, does that help support our case? I'm not sure that makes a difference, except that one of them was 100% all the time, just like seems to have not needed any extra REM sleep. In fact, that might be the answer. It might be based on the fact that one seal showed they needed no extra REM sleep. So I might look for that in the answers too. Of course, I'm just trying to make a predicted or guessed answer. And I may or may not have the right. There might be a couple options that show it. So let's go ahead and check the answers. A. So they determined these seals did not need the extra REM sleep. Based in the study, didn't show significantly less REM sleep during the second day after returning to land than they did during the first day. So the fact that the seals in the study didn't show significantly less REM sleep during the second day, I'm not sure that really even proves our point. So they compensate for deprivation by increasing subsequent REM sleep. It didn't say that it happens all in one day, so I don't know as though this is relevant. B. They showed no significant differences from one another in baseline levels of REM sleep. From one another, so they were all the same? No, they weren't. That's just not true. On the graph, that's not true. They were at different levels of baseline, and that changed. They didn't consistently demonstrate a significant increase in REM sleep after their period of deprivation in the water. Yeah, you could say that. One of them had no sort of significant increase in REM sleep. But again, we're comparing after their period. Increase relative to what? Is baseline what they were at in the water, or they were at zero? They had zero REM sleep in the water. So an increase would be relative to baseline. This is just showing, again, this graph is not showing a change except from day 1 to day 2. D, they showed no significant difference between REM sleep after returning to land and REM sleep in the water. Well, yes, they did. They showed significant difference. They had zero REM sleep in the water, apparently. Okay? So I don't love C, but this might be right. Let's just check the others again. A, didn't show significantly less REM sleep during the second day after returning to land than they did during the first day. One of them did. I mean, and it was a significant amount, so I'm not sure that even is true. B, showed no significant differences from one another in baseline levels of REM sleep. So I think it's going to have to be C. Didn't consistently demonstrate a significant increase in REM sleep after their period of deprivation in the water. I might say this a little differently. They didn't show really much more than baseline consistently. 3 out of the 6 sort of seal days were at and around 100%. So only half of them needed excess of baseline. This is not quite saying that consistently demonstrated a significant increase. I don't like the word increase here. D, no significant, and that's too extreme as well. So the only possible option here is going to be C, but I don't really like it because it says consistently demonstrate a significant increase in REM sleep. They should be referring to a significant percentage higher than baseline sleep, because they also say in the water, they get almost none. So anything from 0 to baseline or 150% of baseline, or even if it were 60% of baseline, none of them are that low. Those would all be significant increases in REM sleep relative to almost none. So I don't like the wording of this. They should use the words percentage of baseline, because that's really the reason why we can conclude these seals don't, exhibit homeostatic regulated sleep, because they didn't have to put in as a percentage of baseline more than 100% consistently when they got back. Half of them had nothing more than about 100%. That's, I think, the better reasoning would be a better written answer choice. So, again, I don't like it, but that's clearly seems to be the answer in the absence of any better choice.